No placeholders, 4, 9, negative 52, 15. You go through it, you got 4, negative 20, negative 11, 55, 3, negative 15, and 0. So we know that negative 5 is a 0. We know negative 5 is 0. We rewrite it as a term, x plus 5. And now you have 4x squared minus 11x plus 3. And you need to find the other zeros. Well, most of you probably said, okay, what times what's 12, but you add together to get negative 11. Nothing. But you probably thought, I know it's 12 to 1. Oh, it doesn't work because it's positive at the end and negative in the middle, so there's no combination there. That's when you see that happening, that means you have to use quadratic formula. Okay? So this one you have to use quadratic formula. Opposite of b plus or minus the square root b squared minus 4 times a times c all over 2a. If you did happen to look at the book O answers, I believe that one did not have the correct coefficient out in front when it rewrote the 4x squared minus 11x plus 3. I noticed that yesterday during Flex, I hand wrote in a 4 on that one, I believe. But they had this set up correctly because they had an 8 in the denominator. So they knew that the A value was 4, but they just forgot to type it in. So a lot of times, whether you're looking on Slater, whether you're looking at the big book of answers, you've got to be careful about the answers that are given. It's a great way to figure out how they did it, but don't rely upon it as, the end-all be-all, because sometimes it's not right. Okay? So from here, you get 121 minus what? 16 times 3 is 32, 48. 121 minus 48 is some number that 73. So you get 11 plus or minus the square root of 73 all over 8. Those are your two other zeros, along with negative 5. Next up. Do you have a dollar? $34 or $54, which is? Yeah, right. Are you still in 6.5 or is that 6.6? 6.6? Okay. So on 34, it's asking you to first figure out your zeros, so that way you can go and search and factor the rest of it out. So we know our zeros, possible zeros, be at plus or minus 1, 2, 3, 4, 6, and 12. The leading term coefficient is 1, so you don't really need to write it down if you don't want to. It's not a big deal. Okay. So now you start fishing. One, 3, not going to work. Woo! Right. What's negative 1 times negative 12? And that'll get you there. And that happens. It does. And obviously, when you're searching for the zeros here, it's really, really fast. And if you're not cautious with the sign, you can make a dumb mistake. And that's usually the only thing that's going to happen. A dumb mistake will happen. Otherwise, after you do this one, then did you keep going and find another one at like 4? Did it take you a while to get to it? You just gave up? Okay. Oh. What happens then, here you've got it at x plus 1. This is x squared plus x minus 12. If you would have kept going, you would have found one because this factors out to being positive 4, negative 3. If you would have kept going and gotten to negative 3, you would have found a 0. Okay. Oops. Gotcha. Yeah. Oops. No big deal. So you got -1, and this is +4. How's that? What else we got, guys? I want to add some. Yes, sir. 38, 6'6" or 6'5"? 6'6". So this one, you want to go synthetic? You want to do grouping? I'll go synthetic because it's a quick. Okay. We'll go synthetic on this one because you only have ±1 and 2 to worry about, which is kind of nice. Okay. Let's see, 1, 1, 2, 2, 0, 0, no es bueno. Try negative. Bueno. So you have a 0 at -1, which gives you a term, x plus 1, and now I'm left with x squared minus 2. Now you have zeros that are located at -1 and plus or minus root 2. And that's okay that you had the plus 0x there, but remember, that just means there's nothing there. Okay? All right? Yes, sir. For most of them, yes. And the idea is, this is good practice. These are really good practice for looking at which way is going to be the best. But when we get down to ones like this, the 5th degree, 4th degree, those are the ones you're not going to be able to do. Right? I wanted to start, and I don't remember if it was you guys or was it 11th hour that was asking, why are we always doing this with 3rd degree? Oh, that's 11th hour, yeah. Because then I showed them what happens when you get 5th degree. And then it comes down degrees, and you can do it multiple times. Okay? Okay, what do you got? 5 or 6? This one here, the x to the 4th? Oh, you read it on the calendar to do those. I don't think I had. Did I have you do those? That's okay. It's okay. And this is where it gets into the when you get to higher degree things. This is kind of all I wanted. I wanted to show you guys what happens. So we all know that when you're searching to find zeros, what we do is we list out all of the possibles to start with. Factors of the tail plus the and divided by the factors of the leading coefficient. This one is just plus or minus 1, 2, 3, 4, 6, and 12. That's it. Okay. So you start your synthetic division, searching for the zero. We'll start with 1, 1, negative 3, 6, negative 2, negative 12. Nope. Try negative 1. And I'm happy that I found a 0. Exactly. So here's what happens. Since this is now an upper degree polynomial, we're always going to do the next step. This works every time. We know that negative 1 is a 0. So I have a term of x plus 1. That's going to be one of these factors. Now, from here, this just drops down to an x cubed minus 4x plus 10x, or minus 4x squared, excuse me, plus 10x minus 12. What I can do is still use this list of possible zeros and go again and start over. What I do here is I always start with the one I just found, and I check to see, is there multiplicity? This is how you can check for multiplicity. Now here's the deal. If you have a compound number, say 66, and we know that that's, that's not good. Think of an easier one. 24. We have a compound number 24. Twenty-four is divisible by what? 6. If I divide that by 6, what do you get? 4. Okay. Now, was 24 also divisible by 2? And you get what? Is that still divisible by 6? Is this still divisible by 2? Okay. What's happening here is that you can still pull factors out at different times. You can factor out numerically different numbers at different occasions, and it doesn't matter because numbers are composites. You can multiply them all together. Does that make sense? Same thing happens with factors with polynomials. The order in which you multiply terms, it doesn't matter. But what happens is, if I know that if this whole thing isn't divisible by x minus 1, if I can't take off the positive one synthetically, I know that the next one won't happen. Same thing here. If I know I can't divide 24 by 7, I also know that I can't divide 12 by 7. Because if it doesn't work with the composite, it's not going to work with the factors. Does that make sense? So what happens, you use that same idea of math with polynomials. So what we do is we always start over to see if it's a multiplicity. 1, negative 5, 5, 15, and it's not. So then I go to the next one. And I change this to a 2. 1, 2, 2, negative 4, 6, 12, and I have another 0. I have another 0 at 2, which means my next term is x minus 2. Now I'm at x squared minus 2x plus 6. Is that factorable? No. Which means you have to do what? Exactly. That's what this comes in. This is the next step of things we're doing today. This is what I want us to be able to do today. Use synthetic a couple of times to get you to a trinomial. Whether or not that trinomial is factorable or not depends on the numbers. If it's not factorable, just use quadratic formula. Okay? So if we use quadratic formula, we get the opposite of b, which is what? 2 plus or minus 4 minus 4 times 1 times 6 all over 2a.
What's 4 minus 24? Negative 20. What's the square root of negative 20, sir?
You don't know. I think you had. So this becomes 2 plus or minus 2I root 5 all over 2.
And what happens with all of those 2's? They cancel each other out.
So your final answer for your final set of zeros would be at negative 1, 2, and 1 plus or minus I root 5. That's your third and fourth zero.
When you have upper degree polynomials, and really any degree polynomials, as we know, you can easily have situations where you get imaginary numbers. And this just happens to be one of those cases. Now, I know that the textbook itself doesn't say, it just says find real solutions. Well, what fun is that? I'm always going to ask you guys to find all solutions. Okay? And all you have to do is literally, when you find a zero for the first time, check it to see if it's got multiplicity. If not, go to the next number and do it again until you bring it down to a trinomial and check and see if you can factor it or if you can use quadratic. So, yep, multiplicity is like if I have 2 terms of x plus 1, x plus 1. That means the zeros occurred at negative 1, negative 1. It changes direction at negative 1. That's where it is. If you have a repeated zero, it's multiplicity. And I don't mean like the zero as in the number 0. It can be x plus 1, x plus 1, x minus 2. It's still a third degree polynomial with a repeated zero at negative 1. And we'll study more of that as we get into the next one. But the process here is kind of the same. Okay.
So let's see here. On that 6, 6 then, you add up to here. Let's do 41, 43. Let me write this down.
Add to what we've got here. We'll use this as our start off. So it'll be 41, 43.
Which ones look not too terrible?
51 through 54. Let's do 6. Seem decent? All right.
Yeah. You can. Because honestly, this is, for the next 2 days, this is really all that we're doing. Okay? We start to enter in a little bit more of the idea of what certain things mean as we get into Monday of why all of this works. We'll start to look at that. But the basis here is, can we search for those zeros? The spell? They could be, yeah. Yeah, because I wanted to give you some of them that had higher degrees. When you have more than a third degree polynomial, because whenever you synthetically divide after a third degree, what are you left with? Quadratic. If you have a fourth degree polynomial, then you're left with a third degree, then you're left with a quadratic. See where I'm going with that? So you'll be able to synthetically, the higher the degree, the more times you can synthetically divide. You could synthetically divide a quadratic if you really wanted to. So it still works. Sure. We should be done. My best guess is that we'll be done with this entire unit before Thanksgiving. Whether it's Friday, Monday, or Tuesday, it's going to be it'll be one of those few days. I want to get done with I'll get you once again. I want to get done with the big bulk of Y algebras because there might be one little section I could leave off and start with that after break to kind of tie us back into what we were doing. Which I might have to do because, like I'm saying, we're kind of butting up against a little time crunch here. What do you got? 743 days. You should have started 2 years ago. She thinks I'm serious. My best guess, I've kind of paced through a lot of stuff that we're looking at. We probably have about 4-day buffer prior to finals of review stuff, which is plenty. It's 20% of your grade. I mean, seriously, it can't. Finals really don't do much to your grades. Really don't. Well, I mean, all right. That's the only thing. If you're borderline, that's about it. It's very rare that your grade. It's very rare that a final will help your grade go up. I mean, even that. I mean, they're so close. And so, but yeah,